Hey guys, we're back with the notes for 8.3. We're going to do this kind of in 4 sections. So each time I put something on the screen, I'm going to have you pause it, copy what you see, and then we'll talk about what's on the screen. Okay? All right, so we are talking about synthetic division today. This is a way to do long division with polynomials. So you might have a very long dividend, which is the original, okay? And whatever you're dividing it by, the divisor, would need to be a binomial. Okay, so we're taking a polynomial divided by a binomial. There are rules laid out on the top. I will talk you through those, but I think it's easier to see with an example. Okay, all right, so here's what we're going to do. We are going to start by taking our dividend, our polynomial, and we are going to write it out coefficients only. So for instance, I have a 6, a negative 19, a 1 for my x, and then a 6 for my no x. So I write it out 6, negative 19, 1, and 6. You don't need the arrows. I'm just showing you where this all is coming from. Okay. We are going to draw kind of like an L box underneath it. You want to make sure that you are leaving space in here to write. And we're going to put a little bitty square kind of off to the side. In that square, let me zoom in. In that square, we're going to take our divisor. So that's this guy. And we are going to make the opposite sign. So basically, we're giving the solution or the 0. So what minus 3 would make a 0? A positive 3. So that's what we're putting in our box. Okay. All right. Let's go through the process now. And it's typed out in words for you, but I think it's easier to see it. Okay. All right. First thing we do is we take whatever our first coefficient is and we bring him straight down to the bottom. So 6. Second thing we do is we multiply and we are going to write whatever we get up here. So positive 3 times a positive 6 is a positive 18. Okay. Now, what we do between these guys is we are going to add them on the way down. So that's this. So if I get rid of that arrow, so we have it negative 19 plus 18 gives us a negative 1. So that's what I'm putting underneath. Okay. Lots of arrows, but we're going to do the same process again. So we're going to come and multiply this positive 3 times my negative 1. And that gives me a negative 3. So I'm going to write it up here. 1 added with a negative 3 is the exact same as saying 1 minus 3. Okay, so we're still adding. 1 minus 3 gives me a negative 2. We're going to do the same thing again. So positive 3 multiplies with a negative 2. That gives me a negative 6. And then we're going to add down. Remember, if you say 6 plus a negative 6 or 6 minus 6, it's the exact same thing. Get rid of all of that. But we are going to get it to 0. Your goal is to get a 0 here. If you don't get a 0 here, what you're saying is that factor, the divisor, is not a factor of that polynomial. Okay, he doesn't divide evenly. It's like saying if I tried to do 20 divided by 7 with long division, it goes in 2 times, 14, but I have a remainder of 6. This guy down here is the remainder. So our goal is to get a remainder of 0. Hopefully that makes sense. Okay. All right, when we go to write our answer now, here's what it looks like. You can look at this 2 ways. You can look at it like factoring, so saying I need to break this guy into 2 pieces. That would be my divisor times my answer. Or you can look at it this way and say, I'm writing a final answer to a division problem. So if I say the dividend divided by the divisor equals this answer. Okay, make sure you know kind of what's expected in the question so you know how to write your answer. We are going to take this over here now, and we know that we have a 6, a negative 1, and a negative 2. We are going to use an exponent 1 less than what we started with. So we started with x to the 3rd power, which means when I write my answer, I'm going to start with an x squared. So 6x squared minus 1x minus 2. This is my answer. Okay. All right. If you need a second, take it, pause it, copy that down. We're going to try another one. Okay. All right, so I'm going to take my dividend, writing it down with coefficients only. So I have a 1 on the x squared, a negative 7 for the x, and a negative 11 for the no x. I'm going to take my divisor and change his sign to the opposite. So we're going to go positive 8, and we're going to follow that process. So first guy comes down, We put a 1. Then we multiply this guy times him, and we write it here. So 8 times 1 is 8. Then we add it down. -7 plus 8 is a 1. I'm going to follow that process again. 8 times 1, write the answer here, that's an 8. Add it down. -11 plus 8 gives me a -3. Okay? All right, now this time you'll notice we do not have a remainder 0. Okay, so remember how, and you don't have to write this down, but I just want to show you again. Remember if I did 20 divided by 7, you would be saying it goes in 2 times, that gives it 14. 6 is my remainder. And so when we would do this, we would say 2 and 6 out of 7, right? That's how you would say 20 divided by 7 is the same as 2 and 6/7. Okay? We're going to think about it the same way. Whatever you get as your remainder is like a part of the whole that you were dividing by. Okay? All right, so this part was my answer, just like this part is my answer. So if I bring him over here and I'm writing it out, let me zoom in just a little bit. I have a 1 and a 1. So one exponent less would be a 1x plus 1. There's no coefficient. But now I have this remainder 3. It's a negative, so we're going to go minus, and we're going to make it a fraction. So my remainder is going to go out of whatever I was dividing by. Okay, so -3 is left over out of x minus 8. Okay, this would be your answer. So whatever that last number is, if it's not 0, it does mean you have a remainder. Okay, I'm going to zoom out for just a second, pause the screen, copy what you see. Let's go to the next one. All right, if you'll pause the screen, we're going to go through the bottom half in just a second. Pause it, copy what you see, then we'll get started. Wonderful. Okay, example 2 is showing you an example of rule C. You cannot use synthetic division if the leading coefficient is not a 1. So like you have to have an x minus 2 or an x plus 4 or something like that. If you have 3x minus 2 or like 5x plus 4, you cannot use synthetic division for that, okay? I do want to make a note, though, of what this would look like if we were filling it in with coefficients only. So I think we can all agree that we know 9 goes first, right? 9 is my x to the third. But because there's no x squared, you would need to leave a placeholder for that, okay? So we would say plus 0. You could put a 0 in your lineup. It's very possible. You would say, how many x's do I have? Plus 5. And then how many no x's do I have? Minus 8. So even though there's 3 pieces here, if we were going to do synthetic division with this, I would have to have 4 coefficients written down, okay? That's what I want to make sure you knew from that problem. Perfect. Let's talk about the bottom part. All right, so on the bottom part, they're going to give us a polynomial, and they're going to tell us what one of the factors is. We are supposed to factor completely, which means that once we get the first one out, we may have to break it again if it's still quadratic. Okay, let me show you what that looks like. All right, first of all, this is your given factor. That means when I move into my solution option, I have to change the sign. So I want to make sure that in here, I start with a -2. When I'm looking at making my synthetic division box, I'm just matching up my coefficients. So all these numbers match. And then we're ready to move through it, okay? All right, bring your first number down, make it a 3. Multiply and write your answer here. So -2 times 3 is a -6. We're going to add on our way down. -4 plus a -6 gives me -10. We're going to multiply, write it over here. -2 times -10 gives me a positive 20. So -8 plus 20 gives me -8. Again, we're going to multiply around, write it here. -2 and -8 multiplied gives me a positive 16. And when I add those together, I do get 0. So I like to put a check mark when I get a 0. That tells me that it does factor all the way, no remainder, okay? All right, we're going to take this answer and we're going to put it here. Since it said factor completely, it's not asking you to divide. You don't care specifically what the answer is. You want to keep it written as factors. Okay, so a list of multipliers, that give you the original question. All right, so I'm going to fill this in. One exponent less. So that means we have 3x squareds minus 10x's and then minus 8. So from there, you have two different options now. If you're really good at factoring, go ahead, do swing and divide and break it into what you normally would. If synthetic division seems like a way easier answer for you, then we're going to go ahead and continue. All right, so I'm going to go ahead and switch it into pink, make this a little bit bigger. And all I'm going to do is add another row for the boxes. Okay, I'm only going halfway though, because I don't need to include that 0 anymore. I need to tack on another little box out here, but I don't know what the other factor is. All I know, I'm going to zoom in a little bit. All I know is that whatever factors I have to go into this 8. So that gives me a couple different factors to check. I could check positive 8, negative 8. I could check positive 4, negative 4, positive 2, negative 2, positive 1, negative 1. And sometimes it's easier to do these in pencil so that you know if they're going to work out or not, okay? All right, I'm going to switch to blue. I like to start with the smallest ones. It just makes it easier to check so I'm not dealing with such big numbers, okay? So I need you to know what we try on the first time probably won't work. Prepare to erase it and try again, okay? All right, I like to start with positive. So positive 1, I roll through this. Bring down the 3, multiply, add it together, multiply around negative 7, and right now I already know that that's not going to work, okay? All right, so I can erase just these two and this one. While I've got the 1 in there, I'm going to give him a negative. Let's see if we can make it work with a negative. Bring down the 3, multiply around gives me negative 3. Negative 10 and negative 3 is negative 13. If I multiply around, that definitely is not going to give me an 8, right? We're trying to make it come out to be an 8. All right, so 1s are not going to work. Let's try 2. Start with the positive. Bring down the 3. Multiply around gives me 6. Bringing it down gives me a negative 4. Multiplying up gives me a negative 8. Okay, so we got the right number, but they're not going to cancel to make a 0, right? That would make negative 16. So that one's not going to work for us. Let's try a negative 2. So bring down the 3. Multiply gives me negative 6. Put those together, I get negative 16. And if I multiplied again, it still wouldn't work. All right, so what we've learned is 2s and 1s do not work, and that's okay. We keep checking. So let's try 4. All right, bring down the 3. Multiply around gives me 12. Negative 10 plus 12 gives me 2. Multiply around gives me 8. Now we finally get our 0. So what that means is remember that whatever you take here has to be the opposite. So if 4 is a solution, that means x minus 4 is my actual factor. This part of my answer, let me change colors real quick. This part of my answer is going to go here. 3x and a plus 2. We used one exponent less than what we had in the yellow, okay? All right, that is a fully factored problem using synthetic division. So pause the screen if you need to, copy it down, and then let's go to the next page. Great. If you would, pause the screen, copy what you see, and then we'll get started. Awesome. All right, so we're going to do the same kind of thing again. The rational root theorem is just showing you kind of what we did a second ago. If I look at this number negative 18, I can figure out all the different factors that I could possibly use for 18 and use that to eliminate options. So I don't need to check like the number 4. I don't need to check the number 5, but I do need to check positives and negatives of all answers once I get there, okay? They gave me one of them. So they told me we're going to divide by this 0. Remember that whatever you see as the 0 is opposite sign of what the factor is, okay? All right, so I already wrote out my factors over there. I'm going to zoom in. This number is going to go into my box because he's my 0. All right, let's roll through it. Bring down the 1. Negative 3 times 1 gives me a negative 3. Add those together gives me negative 5. Multiply around gives me 15. Add those together gives me negative 6. Multiply around gives me 18. Add those together, I get 0. All right, so I like to do my check mark. This works. So I'm going to copy down. This is my first polynomial. So I have one exponent less, which means we're using a squared. 1x squared minus 5x minus 6. Now, if it was me, and I was factoring this, I would not even hesitate because I know what this is. I know it's going to be an x and an x. I know that numbers that multiply to make a -6 and add up to a -5 would be a -6 and a +1. If factoring seems so easy and obvious to you, use that as your final step. Don't do synthetic division, okay? But if I did not know that, then I would start at the top and do a 1. I would say, all right, now my last number is a 6, which means I don't need to check 18 or 9 anymore. I would start with 1, and I would check him. Start with 1, multiply around is 1, add together makes -4, multiply, nope, that's not going to work. I would try a negative. 1, multiply around gives me -1, that makes -6. Multiply around gives me +6. So right here, I already know that 1 worked, so I would change the sign, and then I know that my answer is x minus 6. Whichever of these methods works for you is fine, but we need to be able to get it all the way to the end so that everything is simplified and factored, okay? Pause the screen if you need to, copy anything you missed, and we're going to talk about this rational root theorem one more time, okay? I would encourage you to write some colors here to help you know who's who. Okay, the way this works is your constant factors, that's your last number in a problem. That's like the blue 4 down here. Okay, so your constant factors. All of the factors of them, positive and negative, would be your numerator, would be the top number. Okay? Your leading coefficient, that's the front number on your highest exponent. That's your denominator, all possible factors of him, okay? So if we were going through this, all my factors of p, that's the 4, I could do a positive or a -1, positive or a -2, positive or a -4. All those numbers go into 4, okay? When it comes to q, that's that front number 5, all the different numbers that go into 5, positive -1, positive -5, okay? That's great. Now when we think about all the possible roots, let me do green so we can think of putting that together. All of these numbers are going to be denominators. All of these numbers are going to be numerators, and we're going to write out every possible combination. So let's do it this way. Zoom in just a little bit. Okay. I like to write them out, plus or minus 1, plus or minus 2, plus or minus 4. And I go through them all with the first denominator. So over 1 would be using this guy. Okay? Now, 1 over 1, 2 over 1, 4 over 1 is pretty easy. That's just plus or minus 1, 2, 4, right? Then I would go through it again. Plus or minus 1, plus or minus 2, plus or minus 4. But now I'm going to use the second denominator. 5, 5, 5. Now, because they're plus or minuses, that technically gives us 2, 4, 6, 8, 10, 12 different possible values that we could check in here, okay? It is not crystal clear. I would always tell you to check whole numbers before you check fractions, okay? All right, so let's come down here. I'm gonna have you pause the screen one last time, copy what you need, and then we'll try and walk through these, okay? All right. First thing it tells us to do is try to factor the polynomial by inspection. If the polynomial doesn't factor, then the rational root theorem helps you. So if I look at that and I just already know what 2x to the third minus 7x squared plus 9 is going to be, then that's awesome. You can do guess and check, figure it out from there. If not, then we start evaluating, okay? All right, so I've labeled these in colors. Let's think about all the different factors of 9, okay? So I've got plus or minus 1, plus or minus 3, plus or minus 9. Then with the 2, I've got to remember that those are my denominators. Remember up here, yellow is the denominator, okay? So I could use those as whole numbers, or I could use them as fractions. 1 over 2 plus or minus 3 over 2 plus or minus 9 over 2. Okay? All right, so this one was like if they were over 1. The bottom one is like if they're over the 2, because those are the only ways. Okay? I always, always, always start with the whole numbers first as I'm checking. Okay? So I'm writing down my coefficients. We've got a 2. We've got a -7. There's no x, so that's going to be a 0. And then the 9's on the end. I'm going to start with the 1's. Okay, so let's start. Try a positive 1. Bring down the 2. Multiply. Add them together. Multiply. Add them together. Multiply. Nope. There's no way that's going to make a 9, so we start again. Let's try a -1. Bring down the 2. Multiply. Add them together. Multiply. Add them together. Multiply. Add them together. All right, first one works. Or second one we tried works. So I'm going to go ahead right now. I'm going to remind you that this guy is going to make a factor. So he changes the sign to x plus 1. And this guy is going to be what's left in here. All right, so we have 2x squared minus 9x plus 9. And we need to go again. Now, because we're going again, 1 is back on the table. It's possible for 1 to get used twice. So we do want to check him again. Okay? All right, let's zoom in. Let's try 1. 2, multiply, add them together. Multiply, it's not going to make a -9. So we start over. Let's try it negative. Start with a 2, multiply. Not going to make a 9. All right. As soon as you know it's not going to work, try a different one. All right, let's do 3. All right, bring down the 2, multiply. -3. Okay, we're in good shape. That gives us a -9 and a 0, right? All right, so if I follow with some colors again, I knew that 3 worked. Oops. So I'm going to write that as x minus 3. Remember, we still have an x plus 1 here. And then this part is going to make my answer. Let's put him in green. So 2x minus 3. All right, that's a fully factored problem. If you need to pause the screen, copy that down, go ahead. Otherwise, we got one more. All right, on this guy, different factors for my last number. Options for 3 are going to be plus or minus 1, plus or minus 3. Options for my leading coefficient, it's just 1. So all I have is over 1, which is just these two numbers, okay? All right. I'm always going to start by trying 1 first, but let's get our coefficients down here. We've got a 1, a 6, a 10, and a 3. There's no missing numbers, all right? All right, starting with the 1, bring down 1, multiply, add them together, multiply, add them together. Way too big, right? I know that's not going to work. Let's try a negative. Bring down the 1, multiply, add them together, multiply, add them together, multiply. Not going to make that 3. All right, so 1 is not going to work. Let's roll with our 3. I'm going to check the positive one first. So 1 down, multiply, 3. Add down gives me 9, multiply, 27. Whoa, way too big. We are going to get way too big. Back it up. Let's make a -3. All right, 1 multiplied by -3. Add them together. Multiply. Add them together. Multiply. Add them together. All right, so this one works. Let's put in our pieces. So starting with, what do we use? Pink over here. Starting with pink. This is my first 0, so I change the sign, x plus 3. And my first long factor is going to be 1x squared plus 3x plus 1. All right, now we got to go again. We have already checked that 1, and he didn't work at all. So I don't have to check 1 again, just to be clear. Okay, if I look at this problem, hopefully you guys could probably look at this and think about the factoring already. If you think about this and there's already a factor leading coefficient of 1, so it would have to be x and x, is there any way that you could multiply to equal a 1, but add up to equal a 3? Is there any way for that to work? Think about if you were doing a t-chart, 1 and 1, negative 1, negative 1. Is there any way to add up to make a 3? No. So in this case, my whole answer, guys, is just going to be this. That's my final factor. I'm not telling you what to divide by. It's possible to have a remainder if you divided, but I'm telling you to factor it, which means if it doesn't factor evenly, you don't use it. This is the final answer. Okay. All right. If you need to pause the screen, copy it down, go ahead. I'm going to edit 5 questions on your assignment. So please, please, please stay on this video for just a second until you can make the changes. Okay. All right. Zoom out if I can just a little bit. There we go. All right. On number 1, I want you to change the 28 to a 25. Number 2, change the 3 to an 8. Number 3, change that minus 5 to a plus 3. Number 4, change the negative 11 to a negative 8. 5, we're going to change the 18 to a 20. 6, we're going to change the 21 to a 28. Please make sure you make those changes so that your answers match the key. That is it for our video. Good luck on 8.3.